Alright, welcome you guys. This is AP Calculus. We'll be talking about continuity and one-sided limits. Okay, so continuity is just basically, can I draw the graph, just basic stuff. Can I draw the graph without picking up and doing an infinite discontinuity or a jump discontinuity or a point discontinuity? Okay, there's also specific definitions for continuity, but let's look at one-sided functions. Okay, first off, let's go to the graphing calculator. I love this. Okay, so y equals x to the third. Okay, so this is a pretty simple function. It's the cube of x. Okay, now if I wanted the limit as x approaches 0. Jeez Louise, there we go. The limit as x approaches 0. I would check it from both sides. Okay, first off, the limit I would have to actually go from the left side, and it seems to approach 0. Okay, and you could also look at a table of values and be able to calculate this stuff too. So it appears to be approaching 0. Okay, and then the right-handed limit, or the right side, is coming from the positive side. So this appears to be approaching 0 as well. So I just drag my graph over. Okay, so I'd say the limit as x approaches 0 would be 0. So that's pretty simple. Okay, now that tells me that there's a limit. Okay, if I can approach from both the left hand and the right hand side. Now if I didn't have that, let's say instead I had something that looks like this, y equals 1 over x. Okay, as I approach 0, I'm approaching positive infinity. As I approach 0, I'm approaching negative infinity. So this one, I would write, does not exist. Okay, so this one does not have a limit at that point. Now, if I picked a point that was actually on the graph, let's say 2, okay, if I picked a different limit, 2, okay, that one would exist. So as I approach 2 from the right-hand side, I'm approaching about 0.5. which is a half. And as I'm approaching it from the left-hand side, I'm approaching 0.5, which is a half. So this one I would say 1/2. Okay, so as you can see, the limits can be different in different spots. Okay, now this one I would say this one has an infinite discontinuity at 0. Okay, but everything else, if you're not at 0, it's continuous. So I could say that the graph has an interval from x is greater than 0 or x is less than 0, but basically everything but x being 0, this graph is continuous. So as long as I say that, I should be cool. Okay. Alright, so some really tricky ones are just looking at actual graphs, especially some really funky ones. Here we go. And I'm borrowing this from a lecture in college. I can define it. I'll cite. Let me see who did this. Dr. Julia Arnold. Okay, and she did a wonderful graph. I love this graph. Okay, but if we take a look at this one. Okay, as you can see, there's 2 points of discontinuity: an infinite discontinuity and then a jump discontinuity. Okay. Now, you need to answer 3 things when you're talking about continuity. Okay, and those 3 things, let me see. No, that's limit. Where's the definition? She wrote down a really good definition of it. Nope. Nope. Where is it? Ah, there it is. Here's the 3 rules. A function f is continuous to the point x equals a if the following conditions are satisfied. F of a is defined. In other words, I get an actual number for it. I can't have an open dot or some kind of infinite discontinuity there. Step number 2, the limit as x approaches a of f of x exists. In other words, I get a number. I'm not getting infinite or do not exist. And number 3, the limit as x approaches a of f of x equals this function. So in other words, number 1 equals number 3 is what number 3 is saying. If a function is not continuous at a point, then it is discontinuous. So in other words, if any of these 3 get answers of no, then I do not have a function. Okay, so for right here, let's say if I pick the point 0, okay, It is defined at 0, so that answers, is f of a defined? Yes. Or f of c, let's use a different letter. Does the limit exist? Yep, it's 0. All right. And if we take a look at it, and let me scroll down a little bit, is f of c defined? In other words, does it equal f of a, what it was defined at? Yeah, 0 equals 0. So this is continuous at 0. Now, if I wanted continuous at a, I would say, is it defined? Yes. There's a solid dot up here, but it's not on the same graph, so that's an issue. Now, does the limit exist? If you remember, limits have to have both a left and a right-hand side approaching the same number. So this one's approaching what appears to be 1, 2, 3, 4, 5, 6, 7, 8 up here, and down here it's approaching like a half. So that limit does not exist. All right, now is f of b defined? Well, this is equal f of let me see. Is f of a defined? Does it actually have a value? No, it doesn't. It does actually have a value. It's 1/2, but it is not equal to 8, which is the limit, supposedly. Well, actually, we don't have a limit, so therefore we cannot even say step b. Okay, now if we go to b, all right, is it defined? No, so we don't even answer any of the other two questions. So you just stop there, okay? So that one's pretty simple and straightforward. So as you guys are working on this stuff, just make sure you take into fact, okay, continuity, can I draw it with a pencil? And one-sided function, am I approaching the same number? Now, the thing that might happen, and I was talking about this with the pre-calc kids. Okay, let's get rid of this. All right, let's say all of a sudden I had a graph, y equals 2x minus 4. Okay, something like that. But then all of a sudden I had a whole discontinuity, or in other words, a piecewise, where I had the point 1 comma, let me see, 1, 2, negative 2, 1 comma 3. Okay, let's say all of a sudden I'm all good, okay, and it looks like I'm approaching, now here's how the limits work. Okay, as I'm approaching 1, it looks like I'm approaching negative 2 from the right-hand side, and if I approach it from the left-hand side, I'm approaching negative 2, so that seems to be equal. But if I actually get to it for my limit, okay, you have to remember, you have to follow this specific rule for limits. Not only do you have to have a left-hand side and a right-hand side limit, okay, but you actually have to equal that limit. Alright, so let a function be that is defined for all values of x close to x equals a and with a possible exception of a itself. Then the limit as x approaches a of f of x is equal to the limit if and only if the limit as x approaches a from the left-hand side or from the right-hand side is equal to the limit as the x approaches from the left-hand side, and it all equals L. Okay, so far I've met that it's approaching the same number. Okay, but then all of a sudden it doesn't equal the same number, because let's say that there was a hole here, heaven forbid, and all of a sudden now my graph's up here, so this wouldn't have a limit. Okay, at this point it would have a limit here. The limit would be 3, it would be 2. As x approaches 3, you would be approaching 2 because it gets the same graph. But let's just say we didn't have that there. Okay, alright, so that's the beautiful thing about finding limits, you guys. They're pretty amazing. Just keep in mind what you're doing and just take your time. Okay? Thank you very much and have a great day. Bye.